Hello friends. In this session, we will see arithmetic operations. So let's start. So again, we'll create a new project. So arithmetic, or I will give example two as a project name. Save. Then I will select a legacy system. 8089C51 RD2. Click OK. Startup code we don't need, so click no. So project is created. Now we'll go for the new file. This is the shortcut. I created a new file. Now I'll save that with the extension arithmetic.asm and save. So I have created a new file. I'll just copy the code. So this is a arithmetic operation, that is conditional operations. So that we'll see some more instructions here. I will just adjust it a bit for our ease of understanding so that we'll know where the labels are given. So this is a program. Let's see how the program is working. So as usual, we start with the org00h and then we'll jump to 30h location and we'll start the program from 30h location. So move r0, 40h. So that's a memory location where we are entering the condition from where the condition is right. Uh, okay, because we have the conditional execution. Depending on what value I give, it has to perform a respective job. Okay, so let's see. So R0 I will be loading with the memory location address. So here I am loading a 40h in the R0. Then I am reading the content of that particular memory location in accumulator A. Here one thing you have to observe, that we are accessing the external memory using R0 register, because the address what I want to access is within 256 bytes of the memory address space. Only then I will be able to access using R0. Otherwise, I have to go for DPTR. Then I move that value to R1. Temporarily, I will save it in R1. Then I will increment the R0. Then I will take the operands which are available at 41 and 42 locations. So I'll take the operand in accumulator, first operand. Then I will move that to B register. Then again I will increment the R0 and I will take the second operand. So first I took the operation, I saved it in R1. Then I took the two operands by incrementing R0 and the operands are available in A and B register now. Now I will check the condition. First is compare and jump if not equal. I'm just checking if the R0 and the content what I have read and the value 00, if they are same or no. If they are equal, that means if the value what I have given, if the option what I have given is 00, it will perform addition operation. If it is not equal, then it will jump to this label. So R1 and this value, if they are not equal, it will jump to this label. If I have given option 00, it will continue to execute, where it will perform the addition operation, add AB. Then after addition, we know that the result will be in accumulator. Then register B, I am clearing to 00. Then I'm checking the clear flag. If the flag is clear, then I don't have to do anything. I'll just go to this instruction where I am again using the jump to last. Otherwise, I'm moving the value of B to 01, indicating that there is a carry generated. So here I am checking the carry flag using GNC. If carry is not there, it will go to skip. If carry is there, B is made 01. Then I am checking the second operation with the 01. If the value given and the value what we have given in the memory location is 0 1, then a subtraction is performed. So first, before doing operation, let's clear the carry flag. Then we have to do the subtraction, because always we have a subtraction with borrow. So whenever we want to do this, before that we have to clear the carry flag. Then we do the subtract operation. Then after operation, the difference will be available in A. Then again similarly we make the B as 0 0, and again I will check the carry flag. In this case, I will make sure that 2's complement value is stored. If the borrow is generated, it will be FF, which will be available in the B. Otherwise, it will be 0. Then the third operation, say if the option entered is 0 2, I'll be doing a multiplication operation. So MUL is an instruction AB. One thing you have to observe, there is no comma separator between A and B here. So after multiplication, the lower byte will be in the accumulator and the higher byte of the result will be in register B. Then we have last operation, that is division operation. So if I have given option 03, then I will be performing division operation DIV AB. And remember, this MUL and DIV work only with AB register. And here we are not giving any comma separator. After division operation, the quotient will be available in A and remainder will be available in register B. Then SJMP last. If any other option is given other than this thing, then it's a default. Then we will make just A and B 0 0 and just leave it. Now in the last level, all we do is we write the data back to the memory locations after incrementing R0. Again, we increment the R0 to 43 and we write the result in that memory location using again MOVX instruction using indirect addressing mode. Okay, so this is the program. So same program can be used modified for the other logical operations also, conditional logical operations. Okay, here I have done conditional mathematical operations. Okay, so yeah, I've saved it. Let's add the program to the project. So we'll go here, we select an ASM, already it is there. So arithmetic, add, close. So I have arithmetic here. I will just build the project. So build is successful. So zero error, zero warning. Then I will go to a debug mode. I have a memory location here. So external memory, I want to go to location 40H. So I will give 40. It will go to 40H. Here where I have to give the operation. So default I will keep it 0 0. Here I will give just 1 and here I will give 2. So now I'm expecting a result to be addition of these two values. Okay. Let's see. I will just execute it directly and then I will just stop. So I can see that the result I got is 3 here. Now I will change the option to 0 1. That is, I want to perform the subtraction now. Now again, I will reset the code and I will run the program again. Now you can see that the difference I got is 1. Now I will change the option to multiplication 0 2, and again I reset the code and run the program. So multiplication 2 into 1 is 2. Then I will make it 0 3. Again reset the code and run the code. So now division 2 by 1 is again 2, because A will have the 2 and B will have the 1. Remember, the first operand is in B and second operand is in A. So it will be 2 by 1. So we have the result starting from 43H. Okay. If I change the operand also, we can see, say for example, I will give FF and okay, and 2, I will give a multiplication operation here. I'll just stop, reset and run. Now you can see the value is FE01 is the result. Like that, we can check for a different operations. Similarly, if you see the disassembly window, as we saw in the previous code, here also from 30H, we will have the code being stored. So here you can see CJN is a 3 byte instruction, move X is a 1 byte instruction, because opcode is only 1 byte, right? That means it will consume only one memory location. So this is a 2 byte instruction. Based on that, we will be able to check how many bytes it will consume. See, this is we can observe that many instructions will have the variable length of storage. That's one of the characteristics of the CISC instruction set. Okay. Also, the execution time also varies. In the next session, we will discuss about that. Okay. So that's it for this video. Thank you. Have a good day.